Good morning. Hello, everyone. I hope you can hear and see me. I welcome you to our third webinar of this series about supercomputing and HPC, so high performance computing. We organize this for you, for newcomers in the supercomputing world. By we, I mean Luxinnovation in partnership with LuxProvide and the University of Luxembourg. Allow me to introduce myself for those that don't know me yet. My name is Ramona Kaula, and I'm working at Luxinnovation, the Luxembourg Innovation Agency. And today, I'm not the only one on stage. Here with me, there is Alban Rousset from LuxProvide. Alban, would you like to briefly introduce yourself, please? Alban? Well, in the meanwhile, I don't know if Alban can hear me. Okay, Alban seems to have some troubles. Maybe you can refresh your page and access again. I'm sorry about this. In the meanwhile, okay. In the meanwhile, I introduce you to the platform and the housekeeping rules of today's webinar. And so we'd like this webinar to be as much interactive as possible. So please don't hesitate to use the webinar tool on your right side of the screen. So we have the chat box, question tab, poll tab, and people tab. Don't hesitate to share your contacts, to present yourself in the chat. And in the chat box, in the chat tab, you can insert your questions about the content into the Q&A tab. And we also have a poll, and I will going now to see with you the poll questions, if you like to answer them. Would be great for us to get your background, to know to whom we are speaking to, and also to adapt our speech to yourself, to your background or to your knowledge. So first question in the poll is, do you foresee the need of supercomputing for your simulations? You can answer yes, no, or maybe. Do you use simulations in your daily work so far? Yes or no? Or do you foresee the need of using simulations in the future? Yes, maybe in 1 year, or no, or yes in 3 years, yes in 5 years, or no, I don't think so, I don't need that. So while I'll give you some time to respond to the questions, to the poll, don't forget to put your questions in the tab. In the question tab, we will have a Q&A session at the end where we'll take all your questions and try to answer them. Don't hesitate to also request from some questions you'd like to see in the next webinars, or what you'd like to see as examples about HPC use cases in the next webinars. So let me introduce you the concept of the HPC Thursday. So HPC Thursdays wants to give the basic of what is a high-performance computing, HPC, or also known as supercomputing. So we had already 2 webinars. The first one about the benefits of your activities that HPC can bring. and the second one introducing you the supercomputers and how to use them efficiently. If you miss them, you can see them on Luxinnovation YouTube channel. So don't hesitate to take the time and look at them if you miss them. So today we are seeing, we will see together what simulations are, why you should use simulations for your activities, and why simulations on a supercomputer. The next session will be on 3rd of March. We'll speak about artificial intelligence and high-performance data analytics and how to draw insights from these large data sets, large data that you may have. Then, yeah, don't forget to register for the next session, as you see the pop-up here. And then we'll go more into the use cases examples in health, in finance, and then in digital history and public administration use cases of HPC. On the 5th of May, we will have a special session about MeluXina, our unique supercomputer here in Luxembourg that's open for business companies as well. So I hope that now Alban will manage to be with us.
Yeah, exactly.
Here and see
Good morning.
Good. Would you like to introduce yourself first? And then
thanks. So first of all, thanks a lot for inviting me to this HPC Thursday. It's a real pleasure to talk about HPC and related fields. So I'm Alban Rousset. I'm currently a senior solution engineer at LuxProvide. My daily missions at LuxProvide are to design, improve, and optimize solutions or models for companies and academies by giving support, but also training in order to fill this gap between regular computer science and high-performance computing.
Great, thank you. So now we may go into this session of today. So we'll see the mimicking reality, the power of virtual simulations. So Alban will present us some, well, why people should use simulations and some examples, use cases examples. Then after that, I will introduce briefly to you the National Competence Center in High Performance Computing. And then we'll take all your questions from the questions tab to be answered. We'll try to answer all your questions. So now I leave the floor to Alban for his presentation and hope you will enjoy it. Alban, the floor is yours. Thank you.
Thank you. So could you see the presentation right now?
Yes, we can see.
Okay, so perfect. So today, let's have a look quickly on how the presentation is actually articulated. So first, I will start with a brief refresher on what is HPC and how does it work. Then we will dive into numerical simulation world before going to use cases, showing the benefits and interest of simulating at scale, with different cases, for example, fleet simulation case, digital twin of a biomass, and bird flocking simulation. And finally, we will conclude and move to question and answer session. So let's dive into the HPC refresher. So in this presentation, actually, I will mainly talk about MeluXina supercomputer, but I really would like to highlight the fact that all the content in this presentation can be applied to any other HPC center or supercomputer, for sure, with small differences. If we do an analogy, it's like you used to drive a car of a certain brand, but you're able to change to another brand, you will not be lost, right? So I will try to vulgarize at most. So a huge part of the detailed and implementation will be unfortunately skipped. So a supercomputer is a lot of computing resources and storage interconnected with a high bandwidth and low latency network. Supercomputers are generally composed of different architectures of computing resources. In that case, can be CPU or accelerators, depending on the needs. We can find CPU, which are actually processors. They are roughly the same family as you have in your laptop or personal computer, but you have also accelerators, such as a graphical card, also called GPU, or more exotic card called FPGA. So to target one or the other architecture, you will need more or less knowledge, as it's shown on the figure. And it will consume more or less energy to get more or less performances to fit your needs. So MeluXina is a worldwide supercomputer of Luxembourg. And MeluXina is articulated over a modular approach composed of CPU, so regular processors, but also accelerators, GPU and FPGA. And of course, additional modules like cloud, storage, and so far and so on. But let's focus only on basic. One of the most important things to understand and to highlight in a supercomputer is actually the interconnection. So represented in blue in the schema, the blue line is actually the interconnections. In the case of MeluXina, the interconnection technology is called InfiniBand, and the InfiniBand offers extreme bandwidth with low latency. So to make it short, you can exchange information from one place to another almost instantaneously. That's a big difference between, let's say, regular computer and supercomputer. Let's split MeluXina in three numbers. So compute, storage, and networking. The number are actually really big and hard to imagine or visualize, right? So I will give you an example right now. We all know Twitter, right? The company is generating in the world 12 terabytes of data per day. That equals to 84 terabytes per week and 4.3 petabytes per year of data generated, which means that MeluXina is able to manage more than 5 years of data generated by Twitter in the world, only on MeluXina. So I hope with this example, it helps a bit you to understand how big is the machine. But then the question is the following: which need HPC is filling, which advantages? We can say that there is three main motivations to use HPC. First, improve time to market or improve time to solution, meaning to get results faster. For instance, the race to COVID-19 medication. Second, to tackle a larger problem. In other terms, moving at larger scale, increasing accuracy, granularity, resolution. And last but not least, to save cost. But cost can be money, right? Time, but also manpower. Those three pillars are actually linked all together, meaning that if you are enable or if you enable one, you will automatically play with the two others. Graphically, I like to represent the three pillars using a radar plot, where each vertex is actually a pillar, and where you can imagine which needs you want to feed first, right? And maybe one last thing before moving to the simulation. This is actually a big difference between a regular computer and a supercomputer. On a supercomputer, you will use a batch scheduler or batch processing. For instance, on your computer, when you want to execute a program, you will get it instantaneously. Like you want to open a Word document, you double click and you will get it. On a supercomputer, it's not always the case, right? So in a supercomputer, we will have to what we call we will have a scheduler, and due to the shared access to the machine and the different resources, So to ensure that each user gets what he requests and avoid chaos, we have a scheduler. So actually, to make it short, that's the same principle at the supermarket. You want to buy an article, and then you have to go to the cashier. Sometimes you have to wait a bit before to get the cashier and pay your article. But in any case, you will have to pay, and you will get your article. You will never be blocked forever in the queue. So I hope this refresher was easy to understand, right? And then we will move to numerical simulations. So numerical simulations are used in almost all fields, from biology, seismic processing, climate, even rendering, and so far and so on. Then the question is, why do they need HPC, and why do they need to simulate and go at scale? So for traditional HPC, but we can also include HPDA and artificial intelligence, remember that there was three main motivations: improve time to market a solution, tackle larger problems, meaning going at scale, for example, and saves cost, money, manpower, and or time. It's also important to notice that there is problems that cannot be solved properly or correctly without running at scale. I will give you a concrete example later. And it is one of the reasons that, for example, neural networks took so long to take off. Created in the 1940s, 1970s, the computational resources were just not here. So that's one of the reasons. So the first example is a fluid simulation with the Philharmonie. In that case, we want to analyze and estimate comfort zone for pedestrians using computational fluid dynamics simulation, also called the CFD simulation. The interest of going at scale in this case is to catch all the different paths and pressure of the wind, keeping like the whole flow of the wind with a maximum of accuracy. For that, we need to increase the resolution of the model. So on the left side, you have a low poly definition model, which can be run actually on a regular computer in, let's say, a decent running time, so a couple of hours. Unfortunately, with this type of model, we are not able to get all the detail and accurate results. Due to the low definition of the model, as you can see, for example, on the left side, the columns or pillars which compose the Philharmonie are transformed into a road surface. The main problem with this resolution and simulation is that due to the inherent iterative processing, like integration over time of the simulation, a small errors or a small accuracy at the beginning becomes bigger and bigger as long as the simulation is running. So at the end, you will get only wrong results or a rough estimation. In contrast, on the right side, you have a high poly definition model with high accuracy. This model requires to use HPC due to the massive number of cells and points to compute solutions. But thanks to this model at scale, due to the high resolution, we are then able to catch all the details and all the flow of the wind, even if the wind is slaloming between pillars. So the high poly model is really hard to run on a regular computer due to first a lack of memory, but mainly due to the running time and execution time. A high resolution simulation without the help of HPC can mainly take weeks, months, or even years to be run. So simulating at scale allows to catch detail and get accurate results to take decision and also to improve design and prototyping. Simulation at scale are computationally intensive and need multiple nodes or processes or accelerators to simulate realistic physics in a decent execution time. Meaning even with HPC, some complex simulations with flight dynamics can take weeks. So I'll let you imagine what's happened if you want to run this thing on a regular computer. It will be years. So I will show you an example of the result for this pedestrian wheel comfort simulation. So this one is actually the simulation of the Philharmonie with high definition, so high poly definition. You can see blue lines, which represent the flow of the wind over the buildings. And this can actually help to understand where are located the best pedestrian zones. So there is different color on the lines, or actually on the streamline, and this different color which actually represent the pressure or the speed of the wind. So that's all for this first example. Right now, we are talking more and more about Industry 4.0, digital twin. So first of all, I would like to start with a definition of a digital twin. So a digital twin is a virtual representation of physical systems. Can be traffic, water, air, etc. So far, so on. A twin is essentially used to get information on an action in a simulated world before the action is carried out in the real world, meaning it can open enormous opportunities. Here, we will get an example of a biomass. So researchers of the University of Luxembourg, and more especially the XDEM team, so led by Professor Benoit Peters in the engineering department, designed this model, which is a digital twin of a biomass. So biomass combustion is widely used for generating electricity in geothermal plants. The combustion process is very complex and requires advanced techniques to minimize harmful gas emission. Efficiency and performance within a combustion chamber can be studied from a physical and numerical model to predict the combustion productivity and, of course, to reduce the cost of experiments. So technically, the digital twin is using two types of simulations that are coupled. One, CFD simulation, which is a computational fluid dynamic simulation, and one discrete element method simulation, also called DEM simulation, to simulate granular media. In that case, it will be wood pellets of roughly 30 millimeters. So on the right side, you can see the picture of the particles, red and yellow, that are moving over the grades of the biomass. Each particle in this picture is actually interacting with its own neighborhood, meaning each particle can be considered independent to the others. So they will have to take care of collisions with others, but also chemical reactions, mass transfer, momentum transfer, and so far and so on. There is roughly in this biomass 500,000 particles continuously in the simulation. The most important things to highlight is that there is two softwares, one to manage CFD simulation and the other to manage discrete element simulation. These two software are coupled, meaning that the particles can influence the air in the combustion chamber, but that the air can also influence the behavior of the particles. For instance, in terms of temperature or motion, etc. The use of large scale is then mandatory. As reaction in chain takes place within the combustion chamber, so pyrolysis, we will get evaporation, chalk combustion. The whole process must be designed and simulated to get realistic results. If the model is not designed and run at scale, without one or another part, reactions cannot be performed properly. And the combustion will not happen, or will happen with a wrong physical phenomena. Here is actually a sample of a digital twin working where you can see the particle bed with different temperature. So at the bottom of the picture, you can see particle with blue and red layers, which basically represents the temperature of the different particles. Then on this picture, you can also see the flow of the air, which is represented by arrows with different colors. Can be blue or red, depending on the temperature or the pressure that the fluid is actually moving. And so inside this combustion chamber, a lot of things happened. And as I already said, without one or the other part of these reactions, nothing will happen. It's also possible to do, as I said, this kind of biomass directly using prototypes. The thing is, like, prototypes take a lot of time to be built and test, and it costs a lot of money and resources. So that's why HPC, and thanks to HPC, actually, numerical simulation and numerical coupled simulation are then able to push a simulation to another level. Thanks to that, we are able to simulate huge simulation and whole process in a decent time. Even a couple of weeks is nothing compared to design and build the real prototype. Imagine something gets wrong, you have to start from the beginning, so you just lose weeks or months of work. So that's why that's really important to use HPC at scale, and that allows us to do new design and new modelization. So thanks to that, researchers are able to reduce CO2 emissions. And it's also possible for new generation of biomass to be designed. And all of that in a couple of hours. A last example, which is definitely less complicated, but really funny. The birds flocking. So I really like this example because it shows that without the right scale, nothing happens. You need a certain scale for your problem, for your model to converge. So the emergent behavior, meaning at macro scale, will happen only with the synergy of a certain number of birds. To do this kind of simulation, we use a branch of artificial intelligence, which is called multi-agent systems technologies. So a multi-agent system is a group or society of agents or program which interact with each other in two ways, cooperatively and or competitively, in order to reach basically their individual or common goals. So a flock is a gathering of individual birds, as you can see of the picture, to forage or to travel collectively. So typically associated with migration. So when you see a bunch of birds, they will move in a certain shape. This shape is not at all chaotic. There is some sense in this shape. So in this use case, we are trying to emulate and simulate the flock to understand the behavior of various animal species. The particularity of this model is the simplicity. The model is composed of three simple rules. The first one at the bottom, which is alignment, which means steer toward average aging of neighbors. The second one, which is the cohesion, which means steer towards average position of neighbors. So, and the last one, the separation, which means birds will avoid neighbors. So kind of repulsion for separation and attraction for cohesion. So normally we can emulate this behavior using these three simple rules. So with those rules, the flock moves in an extremely realistic way, creating complex motions and interaction that would be extremely hard to create otherwise. If you not respect the flock, and if you not respect the minimum number of birds, the flock will not happen. You will just see random birds moving in the air, and that's it. But the fact that you simulate a certain number of birds all together will able and will allow actually birds to align them in a certain cohesion. So we need at least a certain number of birds and to run the simulation at scale to get the right behavior. So I will show you a small example which shows, so that's the 2D behavior. We have black points which actually represent birds, and all those birds apply the three simple rules, and that's it. So you can see a certain cohesion within the motion. So sometimes the separation behavior will take more place. So birds will try to escape, let's say, the big bunch, but at some point they are attracted from each other. So as you can see, we have this wavy shape, which will never happen with only few birds. The study of animal species is really important, actually, to understand, for example, in that case, migration and how they plan to, how the migration is done and why they use this kind of shape to move, what the fear of each animals, etc., and so forth and so on. So let's back this presentation. So yeah, I think it's roughly time to conclude. So I think the main thing to keep in mind is like HPC is accessible to almost everyone. I mean, HPC bring accuracy and flexibility. Not only that's not something untouchable, right? And the fact that HPC helps to simulate things that were not possible a decade ago, open a lot of new possibilities. One last thing, okay, that's a bit of teaser, but I show you the fluid simulations with the Philharmonie. So this simulation is done with computational fluid dynamics, and it takes a couple of hours to be done. Thanks to HPC, my colleague, Dr. Luis Vela, will talk on, I think, on 3rd of March about that. So I think you will have to go. That's really interesting. So he managed to compress this simulation of a couple of hours, thanks to HPC and artificial intelligence, to only a couple of seconds to do exactly the same simulation. So I think, yeah, you will have to go for this one. And I will stop here.
Thank you, Alban. Thanks a lot. It was really interesting to see the results of your simulation using MeluXina. It's pretty amazing, the level of detail that you managed to obtain, and also about the birds. And you can study their movements. And I understood this is also used for other kinds of research to mimic the behavior of birds can be applied also to other research fields, and not just about animals, but also with technologies that can behave the same way as the birds behave, right? Well, thank you. Now I invite our attendees to have a look at the poll. There is a new question to evaluate how was the level of difficulty.
I tried to, yeah.
It is, we tried to have an easier session at the last time because, yeah, last time we understood from your responses it was quite a bit a challenge for some of you. So if you answer the question, helps us a lot to adapt to the next sessions to your level or to your curiosity. I invite you again to ask for HPC use cases in the field that you'd like the most to see some examples. We'll try to provide them and to answer your curiosities. And again, please don't hesitate to put your questions in the questions tab. We will take them in a few minutes to be answered. Now I'm going to present shortly the National Competence Center and what we can do for you that are interested in knowing more about HPC and getting some help to use the HPC in Luxembourg. So the National Competence Center basically is your contact point for high-performance computing and data analytics. We support industry, doesn't matter the size. It could be startup, SME, and big industry. To get to know what's HPC resources and services available in Luxembourg. Not only industry, but we support academia and public administration as well to access and support for using HPC. We are also part of a European network of national competence centers across Europe. And being part of the network is an advantage if you'd like to go abroad for an international collaboration or to know more what's happening at European level. Who is behind the National Competence Center in HPC in Luxembourg? There is Luxinnovation, the National Innovation Agency. We support companies to innovate, to be prepared for tomorrow. And we also help you to find or search for funding opportunities for your innovative projects. There is LuxProvide, and here today is Alban representing LuxProvide, the company that is hosting the national supercomputer MeluXina. So they have HPC system that you could access. They are focused on industries, and SMEs, offering not only the access to HPC resources, but also the support needed to be able to use yourself the infrastructure. And we have also the University of Luxembourg with their HPC system. They are focused on education and training and on excellent science. It's the university offering trainings on HPC, but also LuxProvide is offering trainings, workshops, domain workshop and customer tailored workshops to use HPC. So they give you some tips and tricks there how to do that. So as mentioned before, we want to offer the support to use HPC and supercomputers. So not just providing the infrastructure, MeluXina and university HPC, but we want to offer you also holistic ecosystem or holistic support to be able to operational use. So operational support to use HPC. We also help you explore the financial support that could be available at a national level or European level, and also help you find the right partners or connect to other initiatives at the national level or European level. So basically, what are the kind of services and support services available for you that we can offer? We can help you identify opportunities where HPC could be applied to your business, to your activities, to your research or innovation. We help you find the right partner if you'd like to establish a research and innovation project, and also help you to find funding opportunities and set up your project. We offer technical support with feasibility studies, proof of concept, so you can try out with a small part of your project to try out what you can obtain with HPC, what you could reach. And we give and support you to access HPC resources with the IT support at all levels that you need to be able to use the HPC systems. And we offer and encourage your skills development so that you'll be able to begin to become independent into your usage of HPC resources. So we offer training courses in HPC, as I mentioned before, from the university, or LuxProvide is also delivering HPC trainings with hands-on labs, so you'll be able to try out what you learn. And if there is the need and the request, we can offer also customer and domain specific workshops for your company if you are like a small group that wants to know more about HPC. Then, thanks to our big part of the European network, we have the European outreach to other HPC initiatives, and we can help you if you need international collaboration. We can access knowledge outside the Luxembourg as well. So what to keep in mind, that Luxinnovation is your single point of contact, and you can contact me and I try to support you to understand the HPC ecosystem at national and international level. We help you to identify where HPC can be applied and to find the right project partners, or to put you in contact with the person that can help you further, or to advise on suitable financial support measures that could make your job easier. And whenever you are maybe not ready yet for HPC, there is always the Luxembourg Digital Innovation Hub that supports your digitalization and helps you to reach that level of HPC readiness that allows you to access HPC infrastructures. So I think that's all. Now we can get to the Q&A session. So I see we have one question already in the question tab, but don't hesitate to ask your questions, further questions you may have. I think we can start with this one. So one of our attendees is asking what solver was used for calculation. I think it was for the Philharmonie example you showed, and which turbulence model was selected. It's pretty specific and technical.
Yeah, that's a good question. So really, it was for this model or for the Biomass?
I think for the Philharmonie model.
Okay, so for the Philharmonie, it was a long time ago. The solver used was an incompressible solver, so simple foam from open foam, and I think the turbulence was the classical less, so larger dissimulations for turbulence. I hope it answers your questions. If you need more details.
Great.
Oh, okay. So okay,
yeah,
for the Biomass.
Person is asking, I would also be interested in the answer for the Biomass simulation. Exactly.
So for the Biomass, I was working on this project, so I can give you an answer. Due to the coupled simulations, it's actually a solvers that have been modified for this particular type of simulations, so for the Biomass. And the other solver is actually XDM, the software, so which is developed by Professor Peters and Xavier Besseron at the University of Luxembourg. And this software is actually able to simulate dynamic, so meaning the motion of particles, but also conversion, meaning each particle is able to have chemical reactions, a proper temperature, but also can exchange and be coupled with fluid. So if you want more details, we can actually get in touch, or I can put you in contact with the persons.
Great, thank you. So for any further questions, don't hesitate to put them in the question tab. I don't see any questions, but I invite you to any other questions, but I invite you to put your questions there. I would go through the responses of the poll in the meanwhile. We're waiting for you to tape more questions for Alban. So let's see the results of the poll. Starting from the first one, do you use simulations in your daily work? I see 60% of the respondents are using simulations. Do you foresee the need of using simulations in the future? Well, 56% of people, yes, and in 1 year. 22% of people responding yes in 3 years. And 22% of the respondents, no, I don't think so. Or maybe they don't know yet. And do you foresee, the next question, do you foresee the need of a supercomputer for your simulations? 25% responded as yes, and 75% as maybe. So they don't know yet. Don't forget to answer the last questions. How do you evaluate the level of information provided during today's session? I see that 57% of respondents find easy this session to understand with useful information that was new to me. And 45% think that they were too basic. I already knew everything. Well, we are on the right path for everyone to follow us, at least. I don't know if you have any other questions. Don't hesitate to put it in the question tab. I don't know if you want to add anything else, Alban.
Yeah, regarding your last question in the pool, people say, okay, maybe they don't really need HPC for their simulation. Okay, maybe they don't see right now the need of HPC because maybe you were able to run your simulation on your computer. But if you want to push a bit further, for example, and automatize certain kind of simulations, for example, you have a geometry, and let's imagine we put a flow on this geometry. What we can do, thanks to HPC, is to automatize or optimize some parameters. For example, let's imagine you put a car and put a flow on the car and try to study the aerodynamics. You can do iterative simulations thanks to, for example, some software called Dakota, which is a software which allows you to iterate and run automatically a couple of simulations at the same time. So you need a lot of power. That's why you need HPC to run, for example, 1,000 simulation in once. And then it will optimize automatically and refine your mesh in order to find exactly the objective you get and the objective you want. So maybe you don't see the need right now, but if you want to, let's say, optimize or go beyond your models right now, maybe you can get in contact with LuxProvide or directly with Luxinnovation to see what we can, let's say, or what can HPC bring to your model and your simulations.
Totally agree. You can always get in contact with us to explore the possibilities, not necessarily if you are ready to run your work, your jobs on HPC. Great. Then I would say if you don't have any questions, we try to go towards the end of this session. So don't forget to register and to follow us for the next session on the 3rd of March. I will speak about high performance data analytics with the colleague of Alban, with Luis Vela. He will show us some nice examples, I guess, about how to exploit the large data sets you have, how to draw insights, how to get value from your data that you maybe don't use or you can reuse in new ways thanks to HPC. And I guess there will be some artificial intelligence examples as well, as they are in the middle between simulations and data analytics. Please don't hesitate to contact me or Alban directly if you would like to ask him particular questions on these sessions or other questions you may have, or your particular HPC idea for a project, to see if he can help you or LuxProvide can help you to realize and kick off your HPC enabled projects. And register for the next session. It will be really interesting. Thank you, Alban, again, for being with us today. And yeah, it was really nice to see the examples with HPC and MeluXina results. And we are waiting for our next session on the 3rd of March with your colleague. Thank you for listening and for being with us. Bye.
Bye.